Hi everyone, Mr. Barnes here. Welcome to science class. Today we're going to be talking about electromagnetic radiation. Now to start with, I have a very important question to ask you. If you left a can of Pepsi Max and a can of Solo out in the sun, which one would heat up quicker? Because I did this the other day. I left my can of Pepsi and my can of Solo out in the sun and something happened. So I want you to have a think and have a guess about which one you think heated up quicker, or do you think that they heated up at the same rate? Now we're going to do an experiment on this today and we'll get the results of that. Alright, so which one's going to heat up quicker? We've got our Solo and we've got our Pepsi. So to measure this, I've got two thermometers and we'll put one in each can. We'll put one in each can and we'll wait for them to just adjust so that they're both the same temperature, and then we'll start that. And so we're also going to record our data on a notepad here. So I've got time in one column, we'll start at 0, and then we've got our columns to put our temperatures for our Solo and our Pepsi. And we'll put them down by the heat lamp once they're ready to go. Now, I had to use a special halogen globe. If you use an LED globe, it won't heat up. LED globes are way too efficient and they don't put out much heat. All right, let's just check what our temperature is. Now, these thermometers are not great, but you should be able to see it's around 15 degrees. And the Pepsi's around the same. So we'll put them down by our heat lamp now and we'll see what happens. Make sure that they're the same distance away from the lamp. That looks pretty good. And look at our time. So we're starting at just past 6 o'clock. And so we can write our temperature, our initial temperature down at, say, 16 degrees. So now while that experiment's going on, let's talk about our learning topic. So heat, energy and transfer. We've been talking about heat. What are the three types of heat transfer? Can you remember? We'll look at those in a sec. And by the end of this lesson, you should be able to describe radiant heat and how it behaves. So radiant heat is one of the types of heat transfer. And we've got our experiment where we're conducting to see whether how radiant heat behaves. So the three types of heat energy transfer are radiation, convection, and conduction. So conduction, you should remember, is when you have two materials that are touching each other, the heat will transfer from the greater heat energy to the less heat energy. And the convection is when you have air or a medium like air or water and you heat it up, it rises. But radiant energy is different from those two. So have you ever sat next to a campfire and you can feel the heat coming off the fire? So if you put your hand above the fire, you would feel a lot of heat. You can cook things if you put it above a fire because the convection is coming off the fire. But if you sit to the side of the fire, the energy, the heat that's coming off the fire is not convection, it's actually radiant heat. Now, if you think about the sun and how it warms up the earth, there's no air in space. So how does the heat get from the sun to the earth? So it travels in the form of radiant energy. Radiant energy can travel through a vacuum, it can travel through space because it travels in electromagnetic radiation. So radio waves, microwaves, infrared, the visible light, ultraviolet, X-rays and gamma rays all exist on a spectrum. They're all electromagnetic radiation, but the size of the waves and the frequency at which they travel affects how they behave. So if you have a look at this picture, visible light is the colors that we can see. So red all the way through to violet, and that is electromagnetic radiation that we can see. Now, there's electromagnetic radiation that we can't see. Infrared and ultraviolet are both on either side of the visible light spectrum that human eyes can't see, but we can feel it. If you have ultraviolet light, you can get sunburned, and if you have infrared light, you can often feel the heat from it, even if you can't see it. But there are some animals which can see ultraviolet and infrared. This is a snake called a pit viper, and it has a sense organ on its nose that can actually sense infrared radiation. So it can basically see at night if there's an animal that's giving off heat, like a mouse. It can sense the radiant energy coming off that mouse, and it can see where to strike, even though it's dark and there's no visible light around. Let's have a look back at our experiment and see how that's going, and then we'll come back to this. Alright, so I've let time get a little bit away from me here, so it's slightly more than 5 minutes, but let's just check it and see how we went. So our solo is around 18 degrees, and our Pepsi, whoa, it's all fogged up, is, whoa, look at that, 33 degrees after 5 minutes. Unbelievable. All right, we'll check it in another 5 minutes. Light is electromagnetic radiation, and it can transfer its energy in 3 different ways, or it behaves in 3 different ways when it hits an object. It can reflect off the object, the rays can bounce off it. It can be absorbed by the object, in which case it will transfer its heat to the object, or be transmitted, so it will actually bend through the object. So when light hits glass, when the colors of the light spectrum hit glass, they will go straight through it, because glass doesn't absorb the energy and it doesn't reflect. Or it may reflect a little bit of the energy, but most of the energy will just go straight through it. But today we're going to be talking about absorbing energy and reflecting energy. So when we see colors, when you look at an object and you see the colors, if you look at a tree and you see green, if you look at a car and you see the blue or the red color of the car, how is the light behaving with that object that we can see it? Is the light being absorbed by the object? Is it being reflected by the object, or is it being transmitted? So if you have a red t-shirt, what is actually happening is the light that hits that t-shirt, so all the different colors of the light make up white light as we see it, but all the colors in light will actually be absorbed by the red t-shirt, except for the red part of the light spectrum, which will be reflected off it, and that will bounce back, and our eyes will perceive the t-shirt as being red. So if you have a white object, all light is being reflected back off that object. So it's all reflecting off the object, and we see all the colors together, which makes it look white to us. If you have a black object, all colors of the light spectrum are being absorbed by that object, and so we don't see any light reflected, and that's why the object looks black. So that's how we perceive colors with the electromagnetic spectrum. So with this in mind, we should be able to tell what's happening with our cans. The reason why the black can heated up more than the yellow can is because the black is absorbing all radiant energy, whereas the yellow can is reflecting some of it back. So let's go back and check on that now, and then we'll finish up. All right, here is our final check-in at the 10-minute mark. Let's have a look at how we went. The Solo is around 21, 22 degrees, and the Pepsi, again, it's fogged up. Wow, it's nearly 40 degrees. That is unbelievable, the difference that made, just the color of the can. So let's write that down in our data collection. So we had 20 and 40. And we can actually graph that. So 40, I'll have to add a new data point. And so it's pretty rough. This is rough science, but you can see that there's a major difference that has confirmed our theory that the black can heated up a lot faster than the yellow can did. Right, so we can see from that experiment that the black can absorbed a lot more radiant energy than the yellow can did. That's because obviously the black can is absorbing all radiant energy which is being transmitted to it, whereas the yellow can was reflecting back a lot of the yellow part of the spectrum and probably other colors as well. Yellow is quite a bright color, so it's probably reflecting several different colors back. But yeah, that was an interesting experiment, and I hope you learned something from that. One final thought to finish with is, what is one way that you could use this knowledge to keep yourself cool during summer? Have a think about that, and I'll see you next time.